Good afternoon again, everyone. We're going to go over in this part, as you can see on your screen there, some different ideas or maybe some confusion that's out there about filtering a dust collection system, your baghouse, for example. We're going to be able to, in this part, define the difference between a baghouse dust collector and a dust collection system, how that all fits together. How can we look at the big picture of things? At your plants, you probably have a couple different types of dust collectors as well. Are they all created equal? What are the different types of dust collectors that we have? How can we choose the correct one for our application? How is it that the filters actually catch the dust? How does that work exactly? And then talking about our filters for our baghouses or our cartridge collectors, what happens when they fail early? How long can we use our baghouse filters for? How long should they last? We'll be able to talk about that a little bit toward the end of this part. So we want to make sure that, again, we understand these concepts to be able to have our baghouses working well instead of not working at all. And when we do have problems, being able to identify them to prevent them in the future as well. So if we go to the next slide there, Andy, if we look at baghouse dust collection as a system, as a whole, uh, there we go. One concept that we want to make sure that we understand pretty clearly is, what is the purpose of a collector? Why do we have a dust collector in our plants? Real briefly, we have three main reasons there. One is for pollution control. We're creating some sort of dust that might be hazardous or toxic to the environment. It might be a dust that isn't with those different types of things. Sorry about that. But we want to make sure that it is being collected. We might be sanding, we might be cutting, we might be polishing something. We want to make sure that we don't have any type of issue with pollution getting onto the neighbors' houses or people calling pollution control, things like that. Health and safety, as we outlined in the very beginning part of this webinar, worker safety is very important. We want to make sure that everybody is able to work in a clean environment. Having 6 inches of dust on our dust collectors probably isn't the best for that machine, that piece of equipment. It affects overall product quality. It affects overall profitability by not having things clean. Maybe we have operators that, instead of operating different parts of the plant, they're glorified cleaners. They have to pick up the dust and clean the plant in that way. We want to make sure that we can avoid some of those issues. If we have combustible dust as well, all of that dust sitting there, in a way, is kind of waiting for a bad accident to happen, something that could explode or could catch fire very easily. And then thirdly, one of the more common ways is we have some sort of process. We're moving some sort of bulk material from one part of the plant to another. It could be as simple as a trucker blowing into a silo where we have to have some sort of bin vents or even a filter receiver at the top of those silos. We have some sort of process that's creating some sort of dust that does need to be collected. Maybe at your guys' plants, you can think of like a couple different reasons as to why we have collectors. Maybe it even fulfills two or even three of those different reasons there. So again, we don't want to think of just the baghouse as doing all the work. That's the only part of a dust collection system. We want to look at the bigger picture. What are we trying to accomplish? And how are we trying to avoid having any additional dust or nuisance dust? So if we go to the next slide, are all dust collectors created equal? Can we have a bakehouse where we'd have a different type of an application? What are the differences? Well, no. We have different bakehouses or different collectors created for specific reasons. For example, we have our mechanical dust collectors that would be something like a cyclone or a knockout box. It's essentially a dust collector, but just without the filters. Can we use a cyclone in replacement of a baghouse? Well, not really. So we want to make sure that we understand that it's a type of dust collector, but it doesn't replace another type of collector, such as the pulse jet baghouse, for example. Next, we have a specialty collector that could be like our wet collector, a scrubber, precipitator, maybe something that's dealing with a corrosive material. Again, collecting the dust, but acts differently than a cyclone or a traditional baghouse. And finally, we have our filter dust collectors, which probably everybody can think of would be your baghouses, would be your cartridge collectors, filter receiver as well, maybe something that has pleated filters. Again, using some sort of filter to be able to clean the dust or separate the dust from the air. So this afternoon, we're going to talk a little bit more about the fabric filter dust collectors. So if we go to the next slide there, under the umbrella of baghouses or dust collectors, we have a couple different types that we can choose from. Again, we want to make sure we understand the concept of being able to choose the, or correctly choose the collector that we need for our system. We have the first one there, our shaker dust collector. It's a little bit of an older technology, more of our legacy units that we don't see as much today. They're generally a bit less efficient than some of our reverse air baghouses or our pulse jet baghouses. Essentially, you have to shake the baghouse filters with some sort of shaking mechanism, cut off the airflow first. We can't keep operating, we can't keep our process going. So that's why they're a little bit inefficient and we don't see them as much today. Secondly, we have our reverse air bakehouse, which is generally a very large bakehouse for maybe 100,000, 125,000 CFM as a base or larger. Generally, we see reverse air bakehouses at power plants. Essentially, the airflow again is stopped, blown back into the filters to be able to clean them. We don't see these quite as often because, again, we have to have different compartments that either shut down or turned off to be able to clean our bakehouse filters. So we have very specific applications for either a shaker or reverse air. So the much more common bakehouse cartridge collector, dust collector that we see today will be our pulse jets. As you guys probably know, you have a number of them at your plants. These are our collectors that are able to clean online, where we have a burst of air, a pulse of air that's able to clean the bags as the air continues to move through the system. So we can use these for a wide number of industries. We can collect a large amount of dust with these types of collectors. So really, these are kind of our leaders in terms of dust collection. So we'll talk about this a little bit more, a little bit later on in the section when we talk about designing a system. These are some of the different factors that we take into consideration when choosing a specific dust collection system. We want to look at the type of dust, the size of the dust, how much airflow. Sorry, Andy, if we go to the next screen there, factors to consider. Okay, we did take that one out. Okay, very good. That's all right. Like I said, we'll talk about that a little bit later, how we can choose the correct collector for our system in that. So we'll talk about that a little bit later. Sorry about that, guys. We had a last minute change there. All right, so the last concept that we're going to talk about then is our filtering. How is it that the filters actually capture the dust? And how is it that that works within our dust collection system? A lot of times people might call us and ask, how long are my filters supposed to last? Or are dirty filters a bad sign? How often do I need to change them out? Well, let's first understand how our filtering works within our collectors, and we'll be able to talk a little bit more about that in just a few minutes about how long our filters should last. So when we talk about air filtration, we have two primary ways of being able to filter dust from some sort of system. The first one is called depth filtration, as you can see on your screen there. Depth filtration would be like your HEPA filters or your panel filters, for example. They're very efficient at being able to capture even the smallest, tiniest piece of dust. The unfortunate part is that, as you know, if you've worked with HEPAs or panel filters, once they fill with dust, we can't clean them. We can't reuse them. We have to simply change them, toss them. In a dust collection application, these don't work for a baghouse. We have too much dust, we have too much going on to be able to have to keep buying cartridges, once a month, things like that. So what we'll talk about next, in the next slide there, is surface filtration. Surface filtration works a bit different than depth filtration, as you can see on your screens there, where essentially the dust is collected on the outside of our filters. We can think of it maybe like as a fish net. If any of you are fishers out there, we lower the net into the lake or into the ocean. The net is what picks up the fish or anything else that we want to catch, right? These types of filters are stuck to the filter media. These are the ones types of filters that will still allow the air to pass through as well. As the dust gets stuck to the outside of our filters, we can pulse the baghouse to clean the filters. At the same time, we can clean online. So that allows us to be able to clean certain rows of the baghouse while still allowing the air to continue through the system. So they're very efficient in that way as well. Versus depth filtration with our HEPAs or panel filters, filters within our bag houses are able to be cleaned and reused repeatedly. We can get, thousands or tens of thousands of cycles out of our bag house filters, and they're able to handle a very large amount of dust as well, in contrast to our other types of filters. So really, this type of filtration is very efficient, and that's kind of our gold standard when we talk about bag house dust collection. The other great thing about these types of filters and using surface filtration is that we have something that will eventually stick to the filter that's called our dust cake. Eventually, the dust that does get stuck to the filter will develop. And that's why we don't always consider to have a dirty bag house as something bad. Our dust particles that are stuck to that surface of the filter are really assisting the filter in doing the filtering. So it's really a good thing, actually, to be able to have a small layer of dust on them. Our dust collector filters are designed in that way. We obviously don't want to over clean our bag by knocking off all the dust cake from our bags, and we don't want to under clean as well, that our airflow would start to be affected. So we want to find a nice even middle ground there. But again, those are the two main concepts between depth filtration and surface filtration, and why really only surface filtration works within our dust collector and dust collection systems. If we go to the next slide here, if we understand then the concept between depth filtration and surface filtration, how often do we need to change out our filters, or how long should my filters last? Sometimes in some plants that we go to that we visit, the filters have been changed on a regular basis, every one of them within a collector. And in some places, maybe they've never been changed, but whenever a hole is developed with a filter bag, they change it. But perhaps they always spot change every 744 bags within a bag house. What's the idea behind that? Well, we want to be able to identify a little bit more easily when we need to change out our bags. What is the optimal operating condition for our bag houses? So we're going to talk here first about early filter failure versus end of life filter failure. The first concept that we want to understand then is early filter failure, and that's when something damages our filter or causes it to fail. Something that is outside the normal operating guidelines. We can see the picture there of the flat tire. Let's say it hit a nail in the morning. You weren't expecting to drive over a nail with your car. You weren't expecting, to have to go to the mechanic, get it fixed. But whatever you hit, that nail caused your tire to fail. You can't keep driving. You have to stop. You have to fix it. The same thing with our filters on our bag house. Something happened within the bag house where we had to stop, change out that filter, and then we can continue on our way. Generally, we have three different things that can happen: thermal durability, abrasion, or a chemical attack. If we talk about thermal durability, that's one of the more common one that we see today. Temperature. That's basically where the maximum operating temperature of our filters was exceeded. Maybe something got too hot and passed through the bag house. Generally, our filters can only go about 15 or 20 minutes with that excess high temperature rating. Maybe we sucked up a spark or some sort of ember that physically caught the bags on fire, or maybe they just damaged them. So it'd be the first reason as to why our bags would fail, some sort of thermal abrasion, or something that happened via temperature. The second one would be abrasion. Abrasion comes in many different forms. That's where we have different dust particles coming in, and maybe because of a design error with the bag house or the wrong type of bag in our bag house, they weren't able to stand that type of dust. Generally, this abrasion will wear holes toward the bottom of our filters. Also, too, abrasion could come in the form of reusing our old cages. If our old cages are bent or rusty, when our bag house is pulsing, it could be that a bent cage actually rubs against a nice new filter, causes a hole in the bag. Whatever it is, bag abrasion is something we want to avoid because it causes our filters to fail early. And then lastly, we have a chemical attack. The most common one that we see is something that's called hydrolysis, where moisture water is in our airstream, what's going through the baghouse, and causes it to react with other chemicals or compounds that when it goes to the filters, it either attacks them or causes them to fail early. So what concept do we want to understand? We want to avoid these different types of early filter failures to be able to get the most out of our baghouse filters. So the next concept we want to understand then would be our next slide there, early filter failure versus end-of-life failure. End-of-life filter failure is basically being able to use our filters within a normal use until they have worn out. Again, if we go back to the tire illustration, an early bag failure would be like hitting our nail in the driveway. You got to change the tire immediately. You weren't expecting it. Something came up. End of life failure is a lot different when we have driven our car 55,000 miles. Our tread is now gone, but we were able to get a long time out of our tires. Well, the same thing with our filter bags. Eventually, our bags will wear out. We talked a little bit about the dust cape. We'll talk a little bit more about that later. Sometimes when we have bags that have been in our system for such a long time, little particles of dust actually work their way into the depth of the filter media. And as many times as we want to pulse, try to get that dust off, it's embedded into the fabric. So we really can't clean it any more than what's physically possible. Also, cleaning our baghouse filters over time does weaken them as well. They're made of fibers. That can be something that will cause them eventually to get to the end of their natural life as well. So the amount of time it takes to be able to reach end of life failure varies significantly. It varies just as with a car. It depends on how we drive, where we drive, the types of roads that we drive on, the types of tires that we have. A lot of factors are thrown in there, right? With our baghouse filters, it's the same way. Depends on the way the collector is operated, the types of filters that are used, and things like that. But why do we want to help people understand these two concepts? Well, people sometimes obviously get things wrong and they end up changing their filters only on a one-off basis, but all the time. So we want to make sure that we understand what our filters look like by the time they get to the end of their lifespan and be able to tell the difference between those that have been recently changed out. We also want to be able to help the filters get to the end of their life so we can change them all out, not just on a one-off basis. If we need to do that, that's fine, obviously. But the idea, the concept is that we don't want to keep running over nails in our driveway before we go to work every morning. We want to be able to identify that if we have early bag failure, there's some sort of problem, and we want to be able to correct that. So those are some different concepts that we touched on real briefly about our filters, what is a dust collector system as well, how that differs from only the baghouse. So hopefully that clears up a couple concepts that people have as well.